All right, so here in section 5, we are dealing with the rest of your trig identities worksheet, which is from the the double angle identities and the power reducing identities and the half angle identities and the product to sum identities and the sum to product identities. So we're going to go through a bunch of different examples of how you will use those identities to solve equations or simplify expressions. This first question here says solve in the interval 0 to 2 pi for sine of 2x and sine of x. Well, we see sine of 2x right here, which is a double angle identity, and the identity is sine of 2x is equal to 2 sine x cosine x, and then subtracting sine of x, and that equals 0. And then by your powers of algebra, you've got this term and that term. Both of those terms have sine of x in them, so you can factor a sine of x out and get 2 cosine of x minus 1 equals 0. And then from this, because you have this times that equals 0, one of these two things has to be 0. So we can say sine of x equals 0 and 2 cosine x minus 1 equals 0. On the one on the left, to move the sign to the other side, x equals inverse sine of 0. So where on our circle is sine 0? That would be here and there. So pi over 2 and 3 pi over 2. Over here with this one, add 1, divide by 2, and so you'll have cosine of x equals 1/2. X then equals inverse cosine of 1/2. And now where is cosine 1/2? That would be right here and also right there. So pi over 3 and 5 pi over 3. All right, here we are trying to figure out sine, cosine, and tangent of 2u, and we know that u is a negative 2/7, and the value of is in between pi over 2 and pi, so we're in the second quadrant. So we just use the sine 2u, which is 2 sine u cosine u. And we know that cosine of u is a negative 2/7, so we can fill that in. And we have 2 times. We need to figure out what sine of u is. Well, here's where you refer to your friend, the right triangle. Call that angle u, and since this is 2/7, the adjacent is 2, the hypotenuse is 7. No need to worry about the sign when you're trying to figure out the ratio. Let's see then. So to figure out that, you'd say x squared plus 2 squared equals 7 squared. So 49 minus 4 is 45. So this is the square root of 45, which is also 3 square root of 5. And so then we have 3 square root of 5 over 7. And let's see, in this quadrant, sine is positive, so it stays positive. Now all you have to do is multiply things together. 2 times 3 times 2 is 12. 7 times 7 is 49. And the square root of 5, and it would be a negative because of that negative sign right there, because there's only 1 in it. Then cosine of 2u. You have 3 choices for that one. Doesn't matter which one you use, and since I've already figured out what the sine is up here, I could use the cosine squared minus sine squared one. But because I just have this, I'm going to use 2 cosine squared u minus 1. So then, because we know that cosine is a negative 2/7, we we have 2 times a negative 2/7 squared minus 1. And 2/7 squared, negative 2/7 squared is 4/49 times 2 is 8/49 minus 1. And 8/49 minus 1 is the same as 8/49 minus 49/49. So a negative 41/49. Then here we go with tangent of 2u, which is 2 tan u over 1 minus tangent squared of u. So let's see. Tangent from our right triangle then is going to be 3 square root of 5. So tangent of u is 3 square root of 5 over 2. So we have, and it should be a negative, because in this quadrant it's negative, tangent is negative, I should say. So we have 2 times negative 3 square root of 5 over 2, and then 1 minus negative 3 square root of 5 over 2 squared. So then multiplying this out, the 2's will divide, and that's a negative 3 square root of 5. And here you have 1 minus, and if you square this, you're going to have over 4. And that is 45, because 3 squared is 9, and the square root of 5 squared is 5. And 9 times 5 is 45, so 45 over 4, which then 1 minus 45 over 4 equals a negative 41 over 4 times negative 3 squared divided. So then you have to multiply by the reciprocal, and that's going to be 4 over 41. So it's a negative 12 square root of 5 over 41. And there is your tangent. And now if you look at your tangent answer, look at the numerator and denominator of tangent, and then go back and look at your sine answer and your cosine answer. Notice anything about some things in those fractions compared to what is in tangent? Hope you do. Because what do you know about tangent as it relates to sine and cosine? All right, moving on to the next one. Here we just have to simplify this to a single term. Here we have 2 terms. And hey, 6 can be divided out, which would leave you with 1 minus 2 sine squared of x. And then from our properties, we know that, or identities, we know that that is cosine of 2x. And then the 6 would stay there. And there's our one term. Pretty short and sweet. Here we have to write to the first power of cosine. So we have exponents, and we got to get it so that there's no exponents anymore. So we want to reduce our exponents. So first thing, if you look at your sheet, there are power reducing identities, but they are only sine squared, cosine squared, and tangent squared. Here we have cosine to the 4th. Well, another way to write something to the 4th would be to say cosine squared times cosine squared. And then this would be sine squared. And now we know that sine squared is 1 minus cosine 2u over 2. Sine, or cosine squared is 1 plus cosine 2u over 2. And 1 plus cosine 2u over 2. Now we have to multiply this stuff. I'm going to multiply these two together first. So that's 1 plus cosine minus cosine makes nothing. And then that is minus cosine squared of 2u over 4. Okay. Well, now this, we still have a squared thing here, so we've got to get rid of this again. And we know that cosine squared of something is 1 minus, and then 1, oops, cosine squared is 1 plus cosine of 2u over 2. But now this is 2u already, so 2 times that makes that 4u. And then that is all over 4 like so. Now this looks like a big pile of garbage, so we shouldn't leave it like that. Um, that's a negative there, and so if you simplify the numerator first, this turns into 2 over 2, and then we have 2 minus 1, which is a positive 1/2, and then minus cosine of 4u over 2 over 4. Well, then that turns into, if you divide by 2 and divide by 4, that's the same as dividing by 8. So you have 1 minus cosine 4u over 8 times 1 plus cosine 2u over 2. Okay, then we multiply these together now, and we got 1 times 1 is 1. 1 times cosine is plus cosine of 2u. That times that is minus cosine of 4u. And then that times that is minus cosine 4u cosine 2u. And let's see, and that is all over 16. So let's see, we've got first power of cosine here, but here we have a cosine times a cosine, and now we can use one of our product to sum identities, which that is cosine cosine, which is the third one on your sheet. So this turns into 1/2 cosine x minus y plus cosine x plus y. And so this is 4u minus 2u and 4u plus 2u. So that is a negative 1/2 cosine 2u, and it would be a negative 1/2 cosine 6u, because this is a negative half times this thing, and a negative half times that thing. And then you have minus cosine 4u plus cosine 2u and 1, and that's still all over 16. Okay, so 1, now you have 1/16. And then this, hey, you can combine that with this, which 1 minus a half is going to be a half cosine 2u, and then divided by 16 is going to be 32nd cosine 2u minus a 16th cosine 4u, and then minus 1/32nd cosine 6u. And there we have the first power of cosine. Alright, so here we're going to use our half angle identities. And the half angle identities are tangent of x over 2 is equal to plus and minus the square root of 1 minus cosine of x over 2. And let's see, if this is 7 and that's 24, that makes that 25. So 1 minus cosine of x. Now the plus and minus is there depending on where the angle is. And in this case, since we're dealing with a right triangle and it's theta, we're going to have a positive answer here. If they were saying that theta was in some interval, then you would have to figure out where that angle is and where the half angle would be to know what sign to use. All right, so cosine of x is 7 over 25. So you have 1 minus 7 over 25 over 2 square root. And 1 minus 7/25 is 18 over 25 over 2, which then turns it into 9 over 25, and the square root of 9 is 3. And the square root of 25 is 5, so it's a positive 3/5 for sine of theta over 2. Cosine of theta over 2 is plus and minus square root of 1 plus cosine of x over 2. So that's going to be 1 plus 7 over 25 over 2. And let's see, that's going to be 32 over 25 over 2, which is going to make it square root of 16 over 25. And the square root of 16 is 4, and the square root of 25 is 5. So it's 4/5. And then tangent of theta over 2, I'm going to go with 1 minus cosine of x over sine of x. So I only have one thing in the denominator, and cosine is going to be 1 minus 7/25 over 24/25. And let's see, that's going to be 18 over 25 over 24/25. So multiply by the reciprocal, 25/24, and the 25's divide out, and 6 goes into 18 and 24, so that would be 3/4. And look at this answer again, just like the last one, dealing with those things and what you're seeing. Now, these other ones, cotangent and cosecant and secant, there are no identities for those, but you do know that secant is the reciprocal of cosine, so therefore this one has to be 5/4. You know that cotangent is the reciprocal of tangent, so this is 4/3. And you know that cosecant is the reciprocal of sine, so this is 5/3. This is the first part of Chapter 5.